Well, hi there, sports fans. Welcome to another exciting edition of Physics 12. Today we're looking at lesson 2.6, which is on inclined planes. And you've probably seen these kinds of things before, but we're taking it a little, probably a step further than what you've seen before. Here's a typical sort of inclined plane that we'll be dealing with. And as you can see, we have this plane here that's on a certain angle, and we have an object on it that is, will likely be in motion, will be accelerated by the force of gravity down the incline. And so let's look at some more details about these kinds of problems that we will be looking at with inclined planes. So first of all, an object that's sliding down an inclined plane, it has three forces that are acting on it. First of all, it has the force of gravity, straight down in the straight down direction. We have a normal force, which is perpendicular to the surface of the plane now. All right, so this object is sitting on the inclined plane, so the normal force is perpendicular to that surface. And then also we have a friction force, which is in the opposite direction of motion. And so if you notice, we have motion on the diagram there already. So the normal force then, perpendicular to the surface, and the friction force is parallel with the surface, but it's in the opposite direction of the motion, which friction force usually is. And then we have the gravitational force, which is pointing straight down. And then lastly, if the object is at rest, then the forces are the same, except that we use the static frictional force, and the sum of the forces is zero. Right? So if the object is at rest, if it is at rest, the only thing that changes really is that we won't have motion here, and the coefficient of friction will be for the static friction, not kinetic. And then, of course, the sum of the forces then will actually be zero. Well, let's look at how we solve problems with inclined planes. And so naturally we will start with the free body diagram. Once again, surprise, surprise. And this is the kind of thing that we want to put on there immediately. First of all, we'll put our gravitational force vector on there. We'll put our normal force vector on there. Friction, if there is any, and the direction of motion. Notice what we've done is we've taken the XY axis and just turned it so that, or rotated it such that the X axis now is parallel with the surface of the plane. And then the Y direction now is perpendicular to that. And that's going to make it a whole lot easier in order to solve these kinds of problems. So that's the first thing that we've done. Also, we want to put our acceleration on there. If there's going to be acceleration, you want to indicate what direction that's going to be, and that's going to be down the plane in this case. Again, motion is already on there, direction of motion, which means then that our friction force then will be opposite to the direction of motion. And again, that's why it's a good idea just to put motion on there, because you know friction force will be opposite to that. And so then it just helps you with not making mistakes on direction with some of your vectors. Then also, we need to know the angle of the inclined plane. Sometimes you're asked, that's the problem, is to find that angle. But if you have the angle, then we do need to know that, because what we're going to do is we actually take the force of gravity and we separate it into its X and Y components. Now again, that's because we've rotated our XY axis, so that means then that we need our components of our gravity force. And so the components then will be this one. The Y component of gravity is called the squeeze force, and the X component of gravity is called the slide force, which makes sense because the Y component is what creates the squeeze between the object and the surface of the plane, and the slide is the force that's going to actually accelerate the object down the plane. So when we know the angle, this angle here, then this angle will be the same. So those two angles will be the same, and that's helpful in order to solve the problems. So this squeeze force then, the squeeze force is going to equal the force of gravity times the cos of the angle theta. So this component here will be Fg cos theta. The slide force is going to be Fg sine theta, all right, which we have right here. So the slide force, Fg sine theta. And then the normal force then, the normal force will equal the squeeze force, provided there aren't any other forces in the y direction, and sometimes there are, but in this case we don't have any, so that means that the normal force has to equal the squeeze force, which is Fg cos theta. And that's also useful because we need to know the force of friction, often for solving these kinds of problems. All right, so here's an example. We'll put some numbers in. Find the acceleration of the mass, which is 5 kilograms. So we're given the information here. We have the angle of the inclined plane, we have the coefficient of friction, and we have the mass of the object, which is 5 kilograms. So we want to determine what is its acceleration. All right, so your free body diagram, this is what you want to put on there. So you want the direction of motion, put your normal force, force of friction, force of gravity, plus the components, the squeeze component and the slide component, and the direction of your acceleration. So first find the force of friction, which is mu Fn, and Fn we said is the same as the squeeze force in this case because there are no other forces in the y direction. So that's going to be mu Fg cos theta because the squeeze force is Fg cos theta. And now we can just put our numbers in. Mu is 0.20, the mass is 5 kilograms, G is 9.8, and cos of 35 degrees. And we get 8.027 newtons for the force of friction. Then we'll find the slide component. The slide component is Fg sine theta. Put the numbers in, 5 times 9.8 times the sine of 35 degrees now, which is 28.10 newtons. Okay, again, this angle here as well. Well, we won't worry about it. And in any case, this angle right here then is 35 degrees because it's the same as that angle right there. All right, so lastly then, now that we have the two forces that are acting in the x direction, now we can find the net force on the object, and that's going to be the slide force minus the friction force, and we've calculated those already. So it's the slide minus the friction, 28.10 minus 8.207 has to equal 5a. That's the mass of the object. So then when we do the math then, the acceleration is 20.07 over 5, which is 4.0 meters per second squared. So our object then will accelerate at 4.01 meters per second squared. And this is the way that you would solve a problem like this. And again, the whole key is the free body diagram. Make sure you get everything on there. Include your direction of motion as well as the acceleration. And once again, just by doing that, then that'll take you a long way in solving these kinds of problems.